So we'll talk about hypergeometric distribution. Even though it sounds complex, but the reality is that it is very much like binomial distribution. The only difference is that when the trials are not independent, then you have to use the hypergeometric distribution rather than binomial distribution. So, for example, a urn contains 6 red balls and 14 yellow balls. Now we pick up 5 balls randomly, and here is the keyword, without. So you pick up one ball and then you pick up the other ball and then you pick up the other ball. So, and if the question is what is the probability that exactly 4 red balls are chosen. So there is the question about success of each trial, and there is each trial has a success or failure, because when you pick up one ball, it can either be a red ball, which is a success, or a yellow ball, which would be a failure. But the probability of each trial success depends on what happened in the prior trial. So these are not independent trials. So binomial distribution will not apply. However, if we are randomly selecting 5 balls, so how do we solve this? If we are randomly selecting 5 balls, then any combination of 5 balls is equally likely. So we are going to do probability of exactly 4 red balls will be number of samples that result in 4 red balls and 1 yellow ball divided by number of possible samples of 5. And this, by combinatorial analysis, we can say that this is going to be 6 choose 4 and 14 choose 1. These are the possible combinations that can result in 4 red balls and 1 yellow ball, and 20 choose 5 is the total possible samples. So this will be 15. If you solve it, 15 times 14 divided by 15 times 4, or 154, so that will come out to be 0.01354. Now if we do it with replacement, then we can use the binomial formula, which is the probability of x is equal to 4, that is 5. It's by 5 by 4, because as we know the binomial formula is n times x, probability of x 1 minus p n minus x. So 5, which is n is 5, and we are success, and we are choosing 4. The sample size is 5 and 4 is the success probability. And what is the probability of each success? Since there are exactly 6 red balls, so the probability is going to be 6 by 20, and then we take it up by 4, and then 1 minus 6 by 20, and this is going to be 5 minus 4. So this will come out to be 0.082535. So so this is, as you can see, if you do it with replacement, the number is going to be different than you do without replacement. So now creating a uniform formula for binomial distribution. If we are randomly selecting n objects without replacement, from a source that contain a success and n minus a failures. This is big N, which is the total number of samples in the in the source. Then x represents the number of successes. Then p x is equal to a x n minus a n minus x divided by nx. Now it may look complex, but it's really what it is just this. In the balls that we have in this example up here, we have successes, which is a, which is 6, and x, or the total a is the total success and x is the number of success in the trials, which is 4. Big N is the total number of objects, which is 14, and a we know is the success. So what number here we are putting is 14, which is n minus a. So n minus a is here because total is 20, so that's 14. And then the number here is n minus x, which is the n objects we are picking every time, which is 5, and 4 is the success, so 4 is 1, so that goes here, so that's why n minus x is 1, and the big N is the 20 here, and x is, this is actually going to be n upon n, not n upon x. N is the samples that you are taking, the n objects you are picking up. So this hypergeometric distribution formula is x is equal to a by x n minus a n minus x divided by n choose n. The maximum value, now these are all intuitive, but the maximum value x can take on will be the minimum of a and n, because the total number of successes cannot be more than the total number of successes that are already there, and it can also not be more than the total number of successes which you are picking up, more than the sample. So, and what is the mean? The mean for hypergeometric distribution is going to be n, which is the total number of objects you are picking, a, which is the number of successes, and n, which is the total number of objects there. So which a is the number of success in the sample, and n is the total objects there, which is basically what it is just the proportion of successes there. And so it looks very much similar to n times p binomial formula, but that is the formula for expected value, and this is the hypergeometric formula. So now we have a few questions we'll do quickly. Question is, suppose a large high school has 1100 female students and 900 male students, and a random sample of 10 is chosen. What is the probability that exactly 7 selected students are female? So probability of x is equal to 7. We can think it logically. You have to choose 7 females, so 1100 are females, so 1100 choose 7, and then the males are 900, and from males you're going to choose 3, and then that is 2000 choose 10, so that comes out to be 0.166490. And you can do it with the formula. In the formula, the n is going to be 2000 and small n is going to be 10, a is going to be 1100 and x is going to be 7.